Good afternoon, everybody. This is Steve Wilson from the State Water Survey, and we're here today to talk about what realtors need to know about homes with water wells. So about today's webinar, this is part of the private well class, if you're not aware, is a national program that's being implemented through RCAP, the Rural Community Assistance Partnership. They're a technical assistance and TA provider around the country, typically for small water and wastewater systems and those systems that, non-community and smaller systems, as well as now for private well owners. So they have staff all around the country who work on private well issues with us. And this webinar follows the 10-lesson class that we developed a few years ago. That's for well owners, and it's available online. We are recording this webinar, and we record all of our webinars, and they're available both on our privatewellclass.org webpage under videos and also on YouTube. Many of you asked questions in advance when you signed up for this webinar, and we'll get to a lot of those at the end today. But there will also be time to ask follow-up questions. In your GoToWebinar screen, there's a question or a chat box. Some have both. I haven't quite figured out whether you get a question box or a chat box or both, depending on what's going on. But if you'll ask your questions in there, Katie will make a list of those during the webinar today, and we'll pull those up at the end. And so, again, I'm at the University of Illinois. I have with me Katie Hollenbeck from the Water Resources Center, who will be fielding questions online and running the logistics today, as well as Dan Webb. You just heard both their voices. Dan's a chemist here at the Water Survey, and he manages our public service lab, which does testing for private well owners in Illinois. So hopefully between the three of us we can answer most of your questions, and we'll get started. So today we're going to talk about really what are important to home buyers and sellers. Well construction basics. I think having an understanding as a realtor of just even the type of well that you might be dealing with is certainly important, especially if it doesn't meet current code versus it does. Basic well water quality information. And then, again, we'll spend about half our time going through questions that we received from you all when you registered. And I'll always point this out at the beginning of webinars that we do for well owners, but it's important for you folks as well. The private wells aren't regulated, so it's really up to the owner and the user to be sure the water's safe to drink. And so in most jurisdictions, it's only well construction that's regulated, and in some jurisdictions, water quality is regulated whenever there's a purchase or home sale, which many of you asked about. But in general, if you own a home and you've lived there and you don't plan to sell your home, you're on your own to make sure your well's safe to use, the water quality is good. And, the one thing I will say with all the notoriety and things that are going on with private wells and water quality and groundwater, a lot of well water and groundwater is completely safe. There's estimated probably 15 to 16 million private wells in use in the United States. And really it's, you hear about the problems, but you don't hear about all the people who've drank water from their well, and their well is safe from surface contaminants and does everything, doing things the right way for maintenance and testing. But that is because, keep in mind that contaminants many times, if you see cloudy water, it may be fine. It may not have any issues, but it can be colorless, odorless, and have no taste. And the things like naturally occurring arsenic, you won't see in a glass of water. And so that's why testing is so important. And the difference is, I know someone asked about the advantages and disadvantages of community versus a private well. I grew up on an old dug well that wasn't safe, but now I live in a community of about 150,000, and I pay $40 to $50 a month so that I know my water coming out of my tap is safe. That's my water bill. That's not really for the water. It's for the maintenance, for all the lines. It's for the folks who run the water system and treat the water if it needs to be treated. It's for all the sampling and infrastructure and just general maintenance. Everything wears out over time. And so that I don't have any worries, I just turn on my tap. The advantage for a private well owner This is all your responsibility, but it also gives you a lot of flexibility. You're basically the operator of a very, very small water system. And then I also threw in here, I pay another $20 a month or so for my sewer bill, which if you're a private well owner, in all likelihood, you also have a septic system that you need to maintain, which we won't get into today. So your client may not understand. So to me, this is all about buyer beware. What you see is there's not a lot of rules, and the rules are inconsistent regarding home sales with private wells. And so what you need to make sure that if you're the seller and you're working with the person who's selling their home, having a poorly constructed well or poor water quality may decrease the value of their home. It may end a few sale opportunities. It's really in their best interest to get their water tested, to have their well inspected, and understand if maybe they're in an area with naturally occurring arsenic. So add an RO unit under the sink, so that you've taken care of that issue. Otherwise, when it comes time, what we tell well owners, and I tell every well owner I talk to ask this question, it's buyer beware. I would not ever buy a home with a private well unless I tested it for all the things that I care about. And that's a lot more than coliform and nitrate. So as a realtor who represents the seller, it's in their best interest to go ahead and do all that stuff up front so that, one, they know what they're up against and what type of constituents they might need to treat for, and they can deal with that head on rather than have it stop a sale or cause the value of their property to go down. So on the buyer side, not only if I'm the buyer am I worried about the health of me and my family, but also, again, property values. So if there's going to be treatment costs or if I have to maintain things, I want to know that up front. I'm not going to go into a property and buy it just because of other reasons. And so what we would recommend to anyone who's going to buy or is selling their home, as well as all the realtors on this call, take our class, go through it. It gives you a lot of good information. It's fairly comprehensive, but it's a basic course on groundwater and wells and what they mean, how they work, what the common problems are, and all that sort of thing. So it's all free, and so it's certainly worth. Our goal is to create a more informed well owner, so that one, they're asking better questions and they understand what's going on. So here's what we recommend: no matter who you represent, test the water, do an inspection, make sure your well's safe. And what that means is that it's sealed from any type of surface contamination, that if it doesn't meet current well construction code, that you can justify why that's the case. Well construction code changes over time. 30 years ago there were no, or 40 years ago there were no well construction codes. So there's a lot of older wells that might have been installed in a way that's not proper or not protective from surface contamination. And again, it's better to be informed and know that up front and to be able to tell your client, hey, here's what you need to do, so that they're aware and understand the situation they're in. There's, too many times you hear, and I have a personal example of the homeowner just trying to get by so they can get it sold the cheapest way they can, and they're really passing on a problem to the next person who buys their house. I think as professionals, we should all avoid that. So a little bit about wells. There's really three types of wells. There are border dug wells, there are sand and gravel drilled wells, and there are bedrock drilled wells. And so we're going to talk about the three types because they're really different and what kind of risk they might pose and where their water's coming from and that sort of thing. So a border dug well. So I grew up, my grandpa hand dug the well that I grew up on a small hog farm in central Illinois in 1933. It's only 14 feet deep. It's uncemented brick, and it used the water that came into our well was from the water table, which means water that's percolating from the surface into the shallow water table and then seeping into our well. And that's because we had no good aquifer that was shallow that they knew of back in 1933 whenever my grandpa built the house at our farm. So these are large diameter because they're meant to be like a cistern, they store water that can seep in slowly because there's no, quote, aquifer where water can be transmitted quickly to the well, like when you're in a situation with like a 6-inch well that's in sand and gravel or bedrock. These days when you bore a well, like this is a boring machine, you can see the hole right underneath the back of the rig. They're basically putting a 36-inch hole in the ground, and then they'll put vertical concrete tile, like the tile that run under a road, the culverts that run under a road, and they set those, are 4-foot sections on top of each other. They've got a little seam, and when you set those on top of each other, they seat on that seam, but it's not watertight, so water can seep in through that. And so, ironically, this is in a bean field. Looks like bean stubble to me, and that seems like one of the worst places you could put a shallow well, is where you're putting chemicals on, for crop production. What am I forgetting? Okay, so these are all dug wells or bored wells. The one on the top left is an old hand-dug well. We're not sure what the diameter is here, but it's covered with 2x8s and 2x10s, and then some sheets of tin, and then some bricks and concrete blocks. This is actually a cattle pasture. You can see the mud around it and the way those posts are worn because of cattle rubbing up against it. So they're doing their business there. It's seeping into the well. It's on a sloped hill with corn above it. This is during the winter. And so you've runoff going into the well. Rats, mice, rabbits, a lot of things can fall into these. And we've seen all of those things in these type of wells. My history, I work at the State Water Survey. We house all the well logs for the state of Illinois. We do a lot of projects, applied research projects, looking at water quality in different parts of Illinois. I've sampled probably 1,000 wells in my career, and we've seen things a lot worse than this picture here, to be honest. The other two pictures here are both bored wells. The one on the right has the concrete tile coming all the way to the surface, and if you remember, if that's a 4-foot section of tile, then about 3 feet underground there's a seam. And so water from even 3 feet below land surface can seep into that well. So if you spill something near here and it can seep down 3 feet, it might be able to get into your well. Not that protective. In some cases, it's the one on the bottom left is also a bored well that it's 3-foot diameter, but it doesn't start until 10 feet down. So they put a cap at 10 feet below land surface, and then they've got a 6-inch pipe that comes up to the surface with a sealed well cap, which is what you're looking at, a red monitor cap. And then they could put 10 foot of clay from surface down to the top of the 3-foot casing, a 3-foot diameter casing, and that gives at least some level of protection from the surface. It's a better design. And so here's both of those. This is a diagram from the Co-op Extension Service in Illinois. The one on the left has a concrete tile coming all the way to the surface. In this case, as a best practice, they're showing 6 inches of concrete all the way around that circular well, so that water can't seep in the top 10 feet or so. On the right is the one I mentioned that has looks like a regular drilled well, and it's really just a 6-inch casing that goes up to the surface, and there's a concrete pad down at 10 feet. And you can see if you look down near the bottom, there's a pump in each one. There's gravel around the difference between the hole diameter and the well diameter, and that shows the geology here. That says sand lens. In our geology, because it's glacial in Illinois, when you run into an area where there's no aquifer, these clays, the glacial clays, may have a 2-inch or a 3-inch sand seam that runs through it, and those are really where the water is being provided. And so that's what this is showing in this diagram. Moving on to sand and gravel wells. So a large sand and gravel aquifer might be as much as 200 feet thick, and if it's full of water, then it might have, about 30% porosity. So if you had a jar of sand, the airspace in that jar would be about 30% of the volume. And so if you imagine that's full of water, then if you have 100 feet of sand and it's full of water, you have about 30 feet of water. That's a lot of water available. Water can move easily through sand. And so this is a picture of a well screen, and this is a woven stainless steel wire that has a specific diameter of an opening between each of those wraps. And the driller, when he drills a well, will collect samples of the sand at depth in the hole that he's drilling to determine the size of the sand grains, and from that he can size the screen to make sure that water can get through but sand can't. You don't want your well to pump sand. That'll ruin your pump and causes a lot of problems because, just like sandblasting the paint off of something, over time that sand is wearing things out. So usually it's for a home well, it's 4 or 5 foot of screen at the bottom and then casing the rest of the way up, whatever depth that might be, and that's usually solid casing. So in the case of a sand and gravel well, let's say you have a 100-foot well, your water is actually coming into the well from 96 to 100 feet, which is great because that means there's 96 feet of protection from the surface. The water has to percolate through sand, maybe clay, to get down there. It's more likely to be stripped of anything that might be harmful from the surface. So typically, if these are fairly deep, they're a pretty safe water supply. So here's just a diagram of what a sand and gravel well might look like. The sand is the blue down here, and the submersible pump. This actually is a poor diagram because you don't put your pump down in the screen typically. That can cause more sand to get through. It's usually up above the screen. In most sand and gravel aquifers, the water level in the well will be at least the top of the aquifer, if not higher, and so you can do that. But there's just a pipe down to the pump. There's wires that go down there, and then the discharge line that it shows with the pitless adapter, at least in Illinois, is 3 or 4 feet below land surface. And the whole point of a pitless adapter is so that you can turn the water horizontally towards your house through the side of the casing at below the frost line so your well doesn't freeze. In the old days, before the advent of the pitless adapter, you had your well in a pit for the very same reason. The top of your well might be 4 feet below land surface because the pipe came out of the top, and you want to make sure that doesn't freeze in the winter. So we still run across those, and they're very dangerous, and I'll talk about that in a little bit. The third type of well, let me go back real quick. So in a sand and gravel well, water is all around the well in the screen, or in the sand and gravel. So that sand and gravel there is saturated, and so once you turn on the pump, it lowers the water level in the well, and water starts flowing toward the well to try to fill in where that low spot is. It's like if you poured water on a table and lifted one end up, water runs downhill to lower pressure, right? And so the same thing in a well, when you start pumping it, you've lowered the water level in the well. It's less than the surrounding sand and gravel, so water is going to try to fill in to make it level. And so that's how a well works. Basically, it's pulling water in from all 360 degrees, and in a sand and gravel aquifer, all that water is available to the well. And the difference with a bedrock well is there's 2 things going on here. One, typically when you drill a bedrock well, you only have casing until 10 or 20 feet into bedrock. If you can see on the right side of the casing, just below the blue where you get into the bedrock part, it says 10 to 20 feet of casing into bedrock. That usually you seat casing into rock, and if the rock is solid enough, the rest of the hole is open. So the bedrock itself acts as the casing. So you can have a 300-foot well in bedrock that might only have 40 feet of casing. And so that means from 40 feet down to 300 feet, water can seep in that well through cracks and fissures anywhere along that depth. And so that's one difference, and one thing that it's really important to understand how much casing there is when you have a bedrock well. We've seen wells that are 300 feet deep that only have 12 feet of casing. That wouldn't be allowed today, but these are older wells, and in that case, anything that can seep down 12 feet from the surface can still get into the well even though it's 300 feet deep. Where if it was a 300-foot sand and gravel well, the only place it can get in the well is the screen that's at the bottom, so it's much more protected. The other difference is bedrock isn't saturated like sand and gravel is. 30% of that volume isn't water that can move freely. Water exists in the cracks and fissures. The most bedrock types, like limestone or dolomite, don't really transmit water. It's the cracks in the rock that allow water to move. So you see it says bedrock fractures down here at the bottom on the left. So the reason you have the casing open hole and you leave it open is so that you can take advantage of those fractures. So if you run into a few of those fractures, now you've got access to water. You can certainly drill a well that's almost through solid rock and miss all the fractures, and you won't have any water, or maybe a gallon or a half gallon a minute. And so being able to tap those fractures is really where your water comes from. As you can see, some of those fractures run back up towards the surface, and that again is the risk. It's almost like a piping system, and so it's only running through the fractures, and so water can be coming from further away, and then your water quality can be influenced over larger distances. So there is a difference. You need to understand, hopefully you have a well log, or you have some understanding of the wells in the area and what might be available, so that when you're looking at a home, you have a feel for what kind of situation that might be. So well type definitely matters, not only the geology, but what you end up seeing is a dug aboard well gets put in when there's really no real aquifer available that might transmit a lot of water. Or in a case like where I grew up, it's a very old well, it's always worked, so why change it? Drilled or driven wells in sand and gravel and drilled wells in bedrock are more typical, and that's what most wells around the country are. It says some cases there may be choices. We've got areas here in Illinois where you might find 1 or 2 or 3 sand and gravel aquifers at different depths that are separated by clays. And so if you stop in the first one, you might have a certain type of water quality. If you stop in the second one, you might have a different water quality, and the third even different. One might have arsenic, one might not. It depends on, those were all laid down by glaciers with different mineralogy, and you can certainly have differences. And even then, when you get below the sand and gravels, you might hit bedrock, and you might have more than one aquifer there. So it's really good to understand those differences. I know in Wisconsin, I believe they've legislated that there's one particular bedrock unit that you cannot finish a well in because it's known to have very high arsenic. And so you can drill and stop above it and finish a well, or if you're going to drill through it to get to a different aquifer below it that has actually better water quality, you have to case off through that unit to make sure that none of that water with high arsenic can get into the well. So, and again, it's best if you have a log. And one thing I will mention now is even if you do have a log, you can always take it to your state geological survey, or in Illinois, the water survey or geological survey, and have someone tell you what it means, what's going on in that area, what's typical for wells in a given region. One of the jobs I have is if a well owner calls me in Illinois and says, hey, I just bought this property in McLean County and it's at this location, what can I expect? How deep of a well do I need to drill? What kind of water quality do I have? We have that information. And I can say, well, you're probably over the Muhammad Aquifer. You're going to have a lot of iron in your water. You're going to want a softener. But in some places there might be some arsenic. You need to test it. But if there's ways to deal with that if you have it. So as far as correcting poor construction, as I mentioned earlier, well construction codes have changed a lot in the last 30 years. I know even our code for dug and bored wells changed probably 15 or 20 years ago, where now there's more rules to try to make it safer and to protect better from the surface. But old wells have always been grandfathered in, so even a well that was drilled 25 years ago that met code then might not meet it now for whatever reason. And I'm not saying that that's necessarily makes it more risky, but it means you need to be informed about what those differences are, and if it does mean that there's more risk of surface contamination, because that's really the problem. Most well problems end up being surface contamination problems. If you have nitrate or coliform bacteria in your well, the reason we test for those are because they indicate a pathway into your well, not because they're necessarily dangerous by themselves. So if you have an old well in the pit, or you find an old hand-dug well, it really needs to be looked at and talk to a contractor about what's the best approach to try to prevent potential problems. Not only do they allow surface contamination, but they're a safety hazard. An old well in a pit might be covered by a piece of plywood. here's what can happen. So the Washington State Department of Ecology is the state agency in Washington State that regulates well construction and drillers. And so they have a blog, which you can go to, and I follow their blog. This was from a couple years ago, but they post pictures or diagrams of things when they happen related to private wells. So this well is in an old building. You can see that it looks like there's insulation laying around. There's an old funnel. There's the jet pump, they're sitting the blue pump next to just inside the well. There was a piece of plywood over that whole thing. She probably walked across it 1,000 times. This time it broke. She fell in and it killed her. This isn't a safe way to have your well. And, something should be done with this whole system in the first place before, because it's, like I said, not only is there water quality concerns, rats can fall in, whatever, but also it's a safety concern. So what should you do with these wells? Bring them up to code. Find out what the construction code is in your state. And there are 2 states that don't have well construction code, Pennsylvania and Alaska. And if you're in Pennsylvania, their DEP has a recommended code. It's just not enforceable by law, which, it still floors me today that in today's world that they don't have construction code to at least give some protection to, the homeowner who might be having a well drilled. But again, it's buyer beware, like I said before. And if you have a well in a pit, extend the pipe up above the surface, then fill it in and install pitless if you need to. Your well authority or a contractor can tell you what's the best thing to do for your situation. I know the well I grew up on, my recommendation to the folks there would be, we don't live there, my folks don't live there anymore, if they still use that well, would be to install a different well. It's really not safe, and there's no way to make it safe. In some cases, that's what's going to happen. But they're better off doing that beforehand than waiting until all of a sudden they can't get a loan. No one can get a loan to buy the property because the well won't pass, sampling for bacteria. Same way with abandoned wells. So especially in the country and rural areas, even if they have a nice new constructed drilled well, there's probably an old well on the property somewhere if the farmstead's been there very long. And, at least in Illinois, we started requiring well logs from drillers in 1968. In some states, like New York, it wasn't until 2000. So any well drilled before that may not be on file. And I know we find in our state that typically we don't have half the logs on file, which means in a state like New York, they probably only have about 10% of their wells on file. So there's a lot of undocumented wells, and, they're, again, an abandoned well is a safety hazard. It's also a risk. And if you have a property with one, if I were going to buy that property, I would require them to fill that in, properly abandon it before I'd buy it, because it's a risk. It's a safety risk. It's a risk. If someone gets hurt or it contaminates an aquifer, then the owner is going to be liable, and it's a risk that you really shouldn't take. So, for example, here's a horse that fell in an old well. Here's the bottom picture. A Shelton man falls 45 feet into the well. That's also from the blog for Washington State Department of Ecology. This guy, they fished him out. He was okay. Very lucky. On the left or on the right here are 4 articles. The third one down is Jessica McClure, who, if you remember back in the 90s, she was an 18-month-old, fell down a well. It was covered live on CNN for like 18 hours while they tried to get her out, and that worked out. It was successful. She's fine. But these other 3 here are all from Illinois. And the issue is these old wells harm or kill people a lot more than anyone realizes. All 3 of these articles are from, so the top one's from Galesburg, the middle one's from, I believe, a Chicago suburb. You have Buffalo Grove, and the bottom one's from Sangamon County, which is where our state capital is in Springfield. No one in these other areas probably heard of the other 2 instances. It made a local paper, and that's as far as it went. It's just not a big enough story or whatever, but it happens a lot more than people realize. So it's certainly worth sealing any abandoned well that might be on a property and requiring it as part of a sale. So do an inspection of the well. and water system so that you understand if there's anything to correct, you should do it beforehand. If there needs to be treatment put in place, you can do it beforehand. There's areas in Illinois where there's arsenic, and almost every well in that area will test over 10. And so put an RO unit in the kitchen sink before you start. Make sure people are aware. Otherwise, you risk, like I said, it's buyer beware, and then sometimes the buyers aren't aware, but then you're taking advantage of someone, and it just, again, passes on a problem, and it's a health risk. So as the buyer, certainly protect yourself and require it. I know someone asked a question about what to do about this possibly holding up a sale. There's no bigger investment you can make than in your home for most people, and so it's certainly worth doing regardless. This is from the state of Wisconsin. They have a really unique approach to property transfer for wells and doing inspections. They say their Department of Natural Resources regulates wells and also their drinking water systems. They say that inspection's not required, but if you're going to do an inspection, it has to be done by a licensed driller or contractor, and you have to use this form. And what they've done is they've created a form that goes through their current well construction code, basically, to see if the well is up to code. So this is the top half. And so if you hire an inspector, if I bought a house, I'd hire an inspector and have him do this. And so then the bottom half it looks at what's non-complying to their well construction code. So, if, like down in the comments, it says pre-1991 driven point pipe depth less than 25 feet. Well, we have areas in Illinois where people choose to put in their own well point, a driven pipe, and not use a well driller or anything. You have the right to do that in Illinois as long as it meets our code. But in the old days, you didn't even have to do that. They're more risky because they're shallow. They don't have any kind of grout around them or any of those things. And so some of these are minor issues, like, is it in a floodplain? Well, if it's properly sealed, that won't be that big of a deal. Is it, at least 12 inches above the ground? It might only be 5 inches above the ground. Is that really an issue? Well, not most of the time, but if it's in a depression or in a spot that's prone to flooding, then it certainly will matter. And so by filling this form out, then you can talk to the inspector who's a licensed contractor or driller, and they can tell you, is this really a problem? How much of a problem will this cause? Is there something we should do to mitigate it in advance? That sort of thing. Or if I'm the buyer, then I'm taking that with me and saying, I'm going to have to do this to my well. I want, $6,000 taken off the price, or you can pay for it in advance. It is, again, buyer beware. So this form is great, though, because I'm going to go back. It says right on the form, inspectors must provide the completed form to the requester of the inspection. Do not send forms to DNR. They don't even want them. They just want to make sure that the person who requests it has the information that they need for a sale of a property, which is, that's the great way to do things. They're regulating the process so that it's done right. They're not trying to step in and be big brother. So I really like their approach personally. So as far as protecting your well, this is from Minnesota Department of Health, and most states have a guide like this that are distances that a well has to be away from a bunch of different things. A graveyard, a poultry building, a feedlot, septic system. This is the top half of the page. Here's the bottom half of the page. A lot of these you might not think of, but these are all meant to be to help protect the well from any kind of influences. So I show this because it's one of the more complete ones I found, but in the state you live in, you're likely to have one of these, again, except possibly in Pennsylvania and Alaska. And so, it's worth, if it's a new well, it has to meet these things. But again, a lot of old wells don't. And I hear stories all the time where there's one house out in the country, it's on an acre lot, and there's farm ground all around it. At some point, that ground gets sold, and now all of a sudden there's 6 homes that are all within a half a mile of each other or whatever on the same side of the road. Well, your well may be 100 feet from your septic system, but is it 100 feet from your neighbor's septic system? And is your neighbor's well 100 feet from your septic system? A lot of times those things aren't checked. And so it's good to know, depending on the state you live in, some have many more rules for septic systems and design and where they're placed, and that information might even be available online or at least at a state agency. I don't believe that's the case in Illinois. But it's good to know where your neighbor's septic is, where your neighbor's well is, all those sorts of things. And again, just showing this again, just because this is a really good document that Wisconsin has, just to go through and look at, all the issues that might be related to a property with a well, where, even looking at the faucets outside, if it's got backflow prevention, things like that. So as far as testing your water, we recommend either way you should test it, whether you're the seller or the buyer. It can be a selling point if it's, what's going on. In most cases, your water is going to come back fine. And if it doesn't, then you can deal with it in advance rather than it causing a sale to fall through or causing a delay or whatever down the road. By being informed and providing that information, it should be a selling point. So, and as a buyer, again, I probably said it a number of times already, it's buyer beware. Test. Also, I recommend testing for chlorine, because one thing that people will do is if their well comes back positive for bacteria, they'll shot chlorinate their well and then take another sample so that they can get that home loan from, if it's a bank or a mortgage company or whatever. So I would test for chlorine, because unless they have chlorine treatment on their system, you shouldn't have chlorine in your water sample. And if you do, that means it was recently disinfected, and I would find a way out. I guess what I'd do in that case is I would suggest running all their taps, their faucets outside, their spigots, let them run for like an hour, and then taking another sample, or having somebody come out later to take a sample, because that's really, that's really the wrong thing to do. And too many times we see where I have a good friend who bought a property, and the only thing they did is sample for bacteria because that's all that was required. And so they really have no idea what their water quality is, if there's anything in it, and they're going to have to test it themselves, which they should have done when they bought the property. So what do you test for? Every situation is different. It depends on the depth and what kind of geology. Some cases there are known contaminants in an area, and I'll show you some examples. But in Illinois we have naturally occurring arsenic in some places, and there's even a few areas where there might be naturally occurring fluoride where you might be concerned. But the way to find that out is ask your county or state health department or a local health district if you're in a state that has those instead of county health departments. And if there's something that's locally concerned, they'll know it. Especially out east, a lot of the bedrock has arsenic or uranium, things like that. And, it's just better to be informed and ask questions in advance. Like if someone called us and asked us about a certain area of the state, we can look at the water quality and give them an idea. We can tell your water's going to be hard and you're going to want a softener. There's a lot of iron for staining, things like that. But we know areas where there might be arsenic as well, and we recommend testing for that there. And again, it's really about being informed. So as far as natural groundwater quality, I mentioned calling resource agencies like us or your state geological survey or your state health department. A lot of times there are going to be nuisance issues like iron, which isn't a health risk, but it certainly can stain your porcelain and things like that. And so in a lot of cases, you can even find things online. And as some examples here, the state of Massachusetts has this web page set up. You can type in your address, and they'll tell you whether you need to be concerned about arsenic or uranium if you have a bedrock well. So, you're going to buy a property and you're in Massachusetts, I'd type in the address and see what it says to say. Oh, and I have a timer on. I'm sorry. Rhode Island, this splotch in the middle, this big splotch, if you can see that, is actually beryllium. I didn't know beryllium was a regulated contaminant until I found this on their webpage. I'm going to go back. Sorry about that. The little circles are all where there used to be orchards that used a lot of arsenic. And so they're giving you some guidance on what you might need to consider. This is the state of Washington, has a really great webpage. They have individual well samples for individual wells where they've sampled in the past. So even if it's not your well, if it's a nearby well, you can zoom in here and see and pull up a sample. This is Wisconsin. Their DNR contracted with Stevens Point, the University of Stevens Point, and they've created this nice web page that allows you to look by county or by township. I pulled up arsenic by county, and so I'm going to pull back here. And so you can see where there might be risk if you're in that area, and you can even zoom in. You can see a lot of the state's fine, but there's a couple areas where there might be a risk. As far as what to sample for, this is what we recommend annually for coliform and nitrate. And as I mentioned before, this really is to be an indicator of a pathway into your well. But we also recommend sampling for this list in the middle. It gives you an idea of the natural groundwater quality, and also will tell you, issues related to lead, if your water might be corrosive, that sort of thing. You can use some of this information and with a health professional to figure that out. And the deal about groundwater, in most cases, the water in an aquifer doesn't change very quickly. It's slow moving. Water is moving. It's a hydrologic cycle. But in general, if I sample like one of the wells I have in Tazewell County, I have some monitoring wells, and if I sample them now and 10 years later, if the arsenic was 40 in one of those wells, it's going to be really close to 40 the next time I sample. The alkalinity is going to be close to the same level. The pH is going to be close to the same. And the point being that if you do an analysis like this every, say, 5 years, if something's really different, like your pH has always been 7.5 or 7.6, and now it's 6.2, then that tells you something's happened. Either there's a crack in your casing, or there's some issue that's caused a problem with your well. And I guess my point is that's why we recommend this. It gives you enough information to understand your water quality and have a good idea that it's either corrosive or not corrosive and how to deal with those things. But the bottom bullet's also important. Contact your local or state health department to find out if there's anything locally like beryllium or uranium or one of those things that you might need to test for. I know in Rhode Island they have people test for, I can't think of the name of it now, it's a gasoline additive. Rhode Island has more of those plants that develop that additive than anywhere else in the country, and so they've added that to the list. Like when you buy or sell a home in Rhode Island, you have to test for, I think it's MTBE, just because they want to make sure that there's not a plume of that material that's made its way to your well. So as far as what to do, as far as informing your client, what we recommend, is provide resources and let them read up on what's going on. They shouldn't go into becoming a well owner, especially if they've never lived on a private well before, so to speak, blind and uninformed. Provide resources. Consider developing a web page. I'll show you an example here in a minute. It could lead to more business for you as a realtor. If you're knowledgeable about groundwater and private wells, then people talk and that sort of thing. Make sure you educate yourself as well as your client. It'll be evident when you're trying to explain things, and that's why we recommend both you and your client take our class if you haven't, and insist on an inspection and sampling even if not required, or if what's required is minimal, like coliform and nitrate. I would not just do those things. I would test for the suite that we recommend, just because in the end, I had a well owner in Macon County, Illinois, contact us. They only tested for coliform and nitrate, and about 16 months later, she had her well tested, and they had 150 ppb of arsenic. And it turns out there's naturally occurring arsenic in that area. Had they contacted us in advance, or their county health department had decided to provide that information, then they would have known that and probably sampled before they bought the property and at least known that they needed to add treatment. This is a family with 4 kids, I think, and they've been drinking that water since they moved in. And so when she called us, she was arguing, obviously very upset, wanted to know why we couldn't change the state laws to protect people, all those sorts of things. And it's buyer beware, so you need to make sure that your client understands that. This is just an example for Illinois. Our Illinois Department of Public Health has all these resources available. Even shows our database, and the GeoSurvey has an interactive mapping feature. You can look at well logs. Then here's Wisconsin's. So most states have information for well owners. And this is the example I wanted to show you earlier, I mentioned earlier. This is the Looper team at Equity Colorado Real Estate. They've got videos on the components of a water system, how a well's drilled. They really try to educate their well owners, I have to go back here, on what it means to be a private well owner and what their rights are. As you move out west, you start running into Western water rights and water law, and you really need to understand those things. It's possible in a few of those states to actually buy a property, build a house, and not have permission to drill a well. And so understanding all that going in is important information. So that's what I have today for our presentation. The rest of the time we'll spend answering questions. We got a lot of questions, and we're going to start going through those. So we appreciate you giving us questions. It helps us understand what everybody's really looking for. A lot of questions on water quality, obviously, and things like that. So first one, though, someone asked, are we available to speak at Realtors conventions? We'd be glad to do that. Certainly don't have resources to go all over the country to every state, but if there's a larger event where you'd want us to come talk about well issues, we do that for environmental health professionals, county sanitarians. We go to their event, their national events, the National Environmental Health Association Conference. We've gone to that the last 3 years and provided information, and be glad to do the same thing. But I will remind you that we record this video, this webinar, and you can certainly use it. It'll be by the end of this week, probably. It'll be on our videos page and on our YouTube page. And you can just look at privatewellclass.org. So someone asked, are sampling results shared with health departments or state agencies? It really depends, only when required. Most of the country that isn't the case, but in some places it is. So New Jersey, Rhode Island, and Oregon, for example, require a water sample at the transfer of property. In New Jersey, the state lab actually comes out and collects the sample. It costs you $600. Now that might be dated. It might have gone up. But they give the results to the buyer and the seller. And that results in New Jersey getting about 13,000 water samples every year. As someone who does research looking at source water protection and aquifers in Illinois, I would love to have 13,000 samples from groundwater every year that we could plot on a map to see where do these things exist? What's the water quality here? They know so much about their state because of that. From that standpoint, it's certainly a good thing. And so, yeah, there's even a county in Westchester County, New York. They require sampling and even take the added step that if it comes up with something that doesn't meet a primary drinking water standard that the EPA set for community water supplies, you have to mitigate that, or they can condemn the property. So, and Rhode Island does the same thing. They work through their home inspectors and consider the water sample part of that, and they basically force you to add treatment or do whatever's necessary to bring that water quality in line, whether it's treatment or another well or whatever. So, most states aren't that way. In Illinois, you're really on your own, especially if you're just sampling your well for your own benefit. If you have it done through our lab, I guess technically that's probably public information. It never really comes up. But if you go through a private lab, it's your business, and who you share it with is up to you. In Illinois, they handle it a different way. We've got a Realtors form that basically asks, are there any adverse issues related to your well or your septic? And you have to answer that supposedly truthfully. And if you're the owner of the property and you're the seller and you answer that untruthfully, or not if you lie about that and it comes up after the property's been sold, they can come back after you for damages. So again, the best move for everyone is really just to provide that data up front and be to make sure everybody's on the same page, on the same playing field. What water quality tests are required for the sale purchase of a new home, and do those requirements vary? So this is a really complicated problem because in some states there are no real rules, and so banks have taken over requiring certain types of sampling in order to make sure that a well might be safe or it's potable water. There's also FHA, VA, and HUD loans, all ran through HUD. Actually, USDA Rural Development and VA all use HUD's rules. So what HUD's rules say now are much different than what they used to be. And so when we did this webinar back last April, I asked this national organization, what are the rules here? And they gave me some answers, and they turned out to be wrong. And so what I've learned since then is this is right from HUD's document. It basically says, first, you have to make sure that there's no opportunity to hook up to a community water supply. And if there is at a reasonable cost, you have to do that first. So even if there's a well there now, in theory, you're supposed to, with a HUD loan, look and see if there's a possibility of hooking up to a community water supply. And if it does, or the costs aren't reasonable, or they are reasonable, you need to do it. Otherwise, you can keep your private well. And then further, it says that if you are going to use an individual water supply, whether that be a well or a spring, the mortgagee must ensure that the water quality meets the requirements of the health authority or jurisdiction. And then if there are no local or state quality standards, it has to meet the standards set by EPA as presented in the National Primary Drinking Water Regulations. So what HUD's saying now is if you have a local health department that has their own rules, you can use those. If not, and your state has rules, you can use those, like New Jersey. And if not, then it's saying you have to sample for all the primary drinking water contaminants. The MCLs that every community is set standard to. If everyone did that, that would probably cost several $1,000s for all those samples for one home. That are in 40 CFR 141 and 142. That's all the primary drinking water contaminants that you hear so much about, like the arsenic rule that changed, or the lead problems that Flint had and all that stuff. So HUD has this document now. It's called 4000.1, and you can Google that. If you just Google HUD 4000.1, it'll come up. It's 1,009 pages. It's actually, from my view as a groundwater hydrologist, it's inconsistent in what it asks people to do, whether it's a new well versus an existing well, inside their own document. And so, there's a lot of misinformation out there, a lot of things that aren't being done the way they're supposed to be. I mentioned the folks in Macon County that only sample for coliform nitrate. It depends on where you're at. I was just in Massachusetts in January, and there are 500 and some odd local health districts. Every one of those districts can set their own standards, and some of them have. And so you could move 2 blocks and be in a different health district and have different set of rules when you're selling or buying a home than from where you just came from. So it's if you want to look at it from where I sit holistically, the idea behind testing is meant to protect public health. We really should be protecting public health equally across the country, not based on some local rule here or lack of a local rule there. And so really it's a system that is difficult to understand. And again, if there are no local rules and then there are no state rules, in theory you have to test for all these things that would cost, like I said, several $1,000s to do. So the problem is that many don't have rules. Some just say coliform nitrate, not understanding that you probably should test, especially for older homes. It's worth testing to see if your water's corrosive because it might have lead or lead solder. There's natural occurring things like arsenic in a lot of places in the country. And so that's why we feel our guidance does a decent job of helping well owners understand what their water quality is wherever they live. And that's also why it's buyer beware. And lastly, there's a lot of misinformation out there as well. So I want to show you this. I actually showed this last time, and I took it off of our video. This is it looks like it comes from HUD. Minimum water quality testing parameters for HUD, US EPA drinking water recommendations for private well water quality testing. A mortgage company in Michigan took an old mortgagee letter from 1994 and that had these listed as what people needed to test for, and they made this nice PDF of it, and it's being passed out around the country as what HUD requires. This has been superseded. It was actually superseded in 1995. It has no bearing. It's not what HUD requires, and if folks are using this, they're not following the rules. And, it looks really professional, if you will, or it looks really like it might have come from HUD, but actually you need to read 4000.1 to understand what they require, and it's what I just showed you. But this is being given to people around the country and saying, here's all you need to test for, and it's not true. It's wrong. So someday it's going to get somebody in trouble, I imagine. Okay, enough about that. So what's the cost of a well inspection? Well, Katie looked online last year and found that they take 1 to 3 hours and they cost $200 to $600. Yeah, and so in some states it's required, others it's not. But I also mentioned New Jersey already, so I won't go back over that. But they also require it's part of their well inspection is also a sample. It costs $600. So someone asked, how do we prepare well for inspection? To me that's, and I don't want to read too much into the way it's worded, but it really shouldn't be about how to make it pass inspection. It should be about understanding if the well is safe or not. And if it's not, how to mitigate that, and whether it's treatment, fixing the problem. It might be there's a crack in the casing. We run across those sorts of things all the time. Or it could be that it's something as simple as the vent screen isn't on the well cap anymore, and so bugs have got it in or whatever. It could be just the opposite. It could be something like the house I grew up on. The only fix there really is to drill a new well. That well isn't safe, nor is it going to not. It never will be safe. You have two choices: drill a new well or add continuous chlorine or disinfection, so that you're treating your water just like a community water supply does, because it's always at risk of surface contamination. So not doing those things really is doing a disservice. And so the example I have, it's friends that had a well that was like the one I grew up on. They chlorinated it 3 times before they could get it to pass the coliform test, which is what the bank for the buyer required for them to sell this farm. And they eventually did. They kept chlorinating the heck out of this well, and they got it to pass. And basically they just passed the same problem on to the next owner that, a month later the well's going to be contaminated with bacteria again, because it's just not a safe well. And, that's part of the problem. We need to try to eliminate those situations and make sure that people are aware that, you're never going to solve this unless you either add continuous treatment or you put in a different well. So it does require testing. You need to understand that to understand your situation, you need to know what your water quality is. You also need to look and see if the well sealed properly and protected the surface. So really it comes back to having your well inspected and tested in advance of selling your home, so that you understand whether you might have those issues or not. So what's a new well cost? This is a really great question, and Katie got some really great answers. So she called randomly drillers. The National Groundwater Association has a list of drillers in each state through their state associations, and she randomly picked drillers in these states and found, we asked about a 300-foot bedrock well. I asked her to ask for steel casing, and so this is what we got. It really depends on where you live. Certainly more urban areas, you're seeing a lot higher costs, and it's really dependent. Michigan, for a PVC well, was 10 to 13,000, but they said to do a steel well, it's over 30. Some of that comes down to individual driller preference. So we have a driller in northern Illinois that will drill through a 30 or 40-foot sand and gravel aquifer to put in a bedrock well, because he doesn't like to use well screen. So he puts in, always puts in bedrock wells. So he might drill a 300-foot well when he could have put in a 90-foot well, which isn't fair to the well owner. And that's just his preference. So if you use that driller, that's what you expect. So there's some of that in here too. How do you abandon a dug well? Well, we just, Katie and I participated in a dug well sealing in Macomb last August. So this property sold with no knowledge by anyone that there was an old dug well on the property. What's unique about this is it was in Macomb, Illinois, which is a town of about 16,000 people, and it was 4 blocks from the town square. So in this part of town, well, in the town itself, they've had city water or been on a community water supply since 1916. So these folks bought this home. They wonder what this concrete slab was next to their back door, and sure enough, it's an old hand-dug, brick-lined well. So, most states have rules for how to abandon wells. Illinois does, and that's what this driller, what happened in this case, the county health department made it a demonstration project. They brought in a driller, and he sealed the well, and they invited county sanitarians from the area, from a bunch of neighboring counties. And so we had a whole group of folks there, and, it was meant to be a demonstration to show them what it would be, what it would look like, and that sort of thing. So the first thing to do is contact your local or county health department and ask what the rules are. And then, because especially in some jurisdictions, they may have rules that are different than the state rules, but most states have their rules online. And if you have a specific place you're looking for, you can contact us. Our email address is info@privatewellclass.org, and we'd be glad to look it up for your state and get you that information. So here's the well sealing demonstration that I mentioned. If you look at the upper right, that's the county sanitarian, Chris, who took some water out of the well before anything was done. So you can see it's right on the corner of where the house is. And when we took the concrete slab off, you can see what it looked like inside. And the picture on the bottom left, you can see there's a young man picking up 2 big bags. There's a full pallet of what's called hole plug, which are bentonite chips. They used an entire pallet on this, and it was only 22 feet deep. So they intermix layers of gravel and layers of bentonite chips according to our code. And you can see on the bottom right where that's the driller, Corwin Gingrich. He's from Iowa, and he's standing on top of that rock that you see in the picture in the bottom center once it got up close enough to land surface, which still takes guts to do in my book. I don't know if I would have stood in there. But anyway, they sealed it all the way to the surface. And again, this is a home that's right in town. And the picture on the upper right, you see a wooden fence in the background. We looked over the fence, and the house next door has one as well. They weren't home. We weren't able to talk to them, but they probably don't realize that they've got an old dug well in their backyard either. So they're all over the place. And, what was interesting about this is there was a small hole where you could see where Chris has taken a square concrete piece out, but there's also a round hole just to the right of that. That was where an old hand pump used to be. It eventually rotted off, and most of that length of pipe was down in the well. And the person who lived there before, we found cigarette butts and several lighters in the well because that's where he went outside to smoke and dropped them in that hole, out of sight, out of mind. So it's just another reason why they're not good to have around. So costs and benefits. Dan, feel free to step in anytime here. Dan looked up some of this information. As far as costs and benefits of private wells, we just covered what it costs to drill a well, but as far as if you need any kind of treatment, in Illinois, most of the time you need a softener. RO units have their own cost if you need any kind of treatment. And I know Dan lives on a private well, and he had to have his pump replaced just recently. So they can last a long time. I believe we asked a bunch of drillers that same question, and we got anywhere from 3 years to 25 years. But I just helped a guy who had his pump had been at least from the 60s, and it just failed. So it really just depends on the type of water, the situation, how much work it has to do, and it's a mechanical device or an electric device, and so they won't last forever. So And I threw on here water testing because, we certainly recommend that you test your water annually. Yeah. And
Good summary, Steve.
yeah, and as far as advantages, Dan pointed out there's no water bill, which, like I said, I'd pay basically $60 to $70 a month for my water and sewer. And so what I tell people is you should be putting that money away anyway, because eventually you will have a pump fail, or you will have to do, you do need to sample your well, so then you've got money for those things. And, another thing Dan mentioned is that, some people are concerned with disinfection byproducts, like that chlorine taste that you might have if you live on a city water where they've chlorinated the water. I know my dad, his philosophy was our well water was always better than city water because it didn't have chemicals in it. Now, our well had frogs in it one time, and that seemed to not bother him as much as he still thought it was better than having city water. So I don't think I agree. But anyway, and as I mentioned earlier, the other advantage is really groundwater is generally safe. There's usually an issue with the well. If it's not, sometimes there can be a naturally occurring contaminant, but those things are treatable. And, the advantage is you can live where you want. I know we lived out in a very rural area. There's no water within miles from a city water supply. And, you're limited if you don't want a well where you can live. So anything else you can think of?
Hey, Steve, I don't know if you'll cover it in a later slide or anything, but you make a good point about setting some money aside. It seems like a good time to talk about shared wells. I don't know how common they are across the country, but around here we have people on shared wells, and usually what happens is they'll put money into a pool. I don't know exactly what it is, maybe a couple $100 a family per year, and then the family who has the well is supposed to take care of problems. But every once in a while we have stories where the owner collected the money but then spent it, and so then when there's a well problem, like a $2,000 or $3,000 well pump, then it's an issue.
Yeah, and that's a really good point, especially for Illinois, because there are no laws that protect anyone. It's kind of you're on your own. And so what I tell people is you need to make sure it's in the deed that you have rights to this well, and have rights that there's some process in place, that it's a shared expense, all those sorts of things, because you certainly run into problems where I know we have actually one of our coworkers here at the Water Survey lives on a shared well, and I asked her, so do you guys, they basically pay a water bill to this one pool, and I asked her, where's that go? And she has no idea. So it'll be interesting if at some point they have a pump fail or one of those issues, what's going to happen. But you need to make sure, again, going back to buyer beware, it's certainly better not to be on a shared well if you can avoid it, just because, it's a good way to make enemies of neighbors, so to speak, if there's problems, but also to protect yourself. So I know there's another case where one home is a lot closer than the other home to the well, and the way the pressure system is set up, when one family is using their well like for showers and stuff, the other home hardly has any pressure, and no one wants to do anything to fix it. And so it's caused a lot of problems for them. And it's, but other states like Washington State, they actually have laws on the books that regulate anything down to 2 homes on a well. So in Washington State, you are on their radar and your regulated system if you share a well with somebody else, which that gives them some control to make sure that they're protecting, individual rights and things like that. And they need to know that stuff just because of Western water law and the way things are out there. Thanks, Dan.
Sure. Seems like it'd be very relevant to buying and selling houses.
Sure.
Knowing if they're knowing if it's a shared well or not.
Yeah, we need to add that in to our presentation, actually. Is lead found in well water? Well, there were several questions about lead, different ones, and I just used this because, one, I want to make it clear that most of the time, it's very rare that it's lead in the natural groundwater. And, we never see that happen, really. There are places where there's natural lead in the ground, lead mines in certain places. There's one in northwestern Illinois, actually. But these problems really occur because of lead in plumbing, either lead pipes or lead solder, sometimes galvanized, those sorts of things, and then corrosive water that allows the lead to leach. And so, I know we're fortunate in Illinois. Dan will tell you that our pH of most groundwater in Illinois is above 7.5, which makes it less likely to be corrosive, although that can still happen, is my understanding. But if you talk to your health department or even your state geological survey in most states or water survey in Illinois, they can tell you if there's actually any kind of lead issue that might be naturally occurring. As far as lead pipes and all that, I mean, we've done an entire webinar on that topic just because, of all the focus that's been on that lately. And so rather than try to explain all that here, if you go to our website, there's a resource page, just private well class/lead. And then if you go to our videos page, private well class/videos, there was a lead webinar done on August 30th, that should be 2016. Made a mistake there. And we use slides from several experts, one from US EPA and one from a researcher at Virginia Tech on research they've done, both talking about lead exposure because of galvanized piping or, corrosive water, but also the US EPA research has done a lot of work looking at carbon filters and how well they work to remove lead, and they actually really do a good job. And so it's one way, putting a carbon filter, GAC filter at your kitchen tap, those that are supposed to move lead actually do a really good job. So those resources are there, and you can read up on lead in a lot more detail or watch the video, the 90-minute video. Okay. Dan, I'll let you answer this one. This is, we always get questions about sulfur and rotten egg smells. So,
yeah, it's a pretty common question for us. We don't test for, it's usually attributed to hydrogen sulfide, and we don't have a test. And I don't know about other labs, but often they say that the rotten egg smell, your nose is pretty sensitive. So by the time you can smell it, the water is often unpalatable, so you don't drink it. But anyway, the common way to get rid of it, it's usually attributed to sulfur-reducing bacteria or sulfate-reducing bacteria. So often you try to get rid of that by some type of a shot chlorination or a continuous chlorination. Sometimes I've talked to some health department professionals who've told their clients to, shot chlorinate several times. Like if there was a layer, it kills a surface layer of bacteria, then you might need to flush it out and keep doing that. If it really doesn't go away, in the long run, you may need to go to continuous chlorination. The other question, I think, was about brown, rusty color or even an iron taste in the water. That's one of our biggest complaints is a brown color, and it's what people complain about, even though it doesn't have a health effect, like Steve, I think, had mentioned earlier. There's a couple things you can do about this sediment, the rust sediment. First, it usually comes from iron just once dissolved in the water and then gets exposed to oxygen and precipitates into a different oxidation state. Sometimes there'll be some sediment with that, and in addition to the iron. So I always tell people to start off with the sediment filter. It's really easy. But also you can get a softener. Most softeners will take out some amount of iron. If you have a lot of iron, you'll have to probably add an iron filter. That's another thing you have to maintain. So if it were me, I'm on a private well, and I don't have an iron filter, and we've got a pretty high amount of iron, anywhere from 2 to 7 parts per million, and my softener does a pretty good job taking it out. Oh yeah, tannins. I see the tannins were listed on here as another brown color. We do have people with like naturally occurring organic material, and there are some filters that can take some of those out. I would just defer that to a water treatment dealer.
All right. Thanks, Dan. So what advice would you give a homeowner considering putting in a whole house versus kitchen RO system? So RO is reverse osmosis. And, to me, it really comes down to, do you really need it? And I don't know the context of why whoever asked this question was asking, but one of the best examples I have is that we have ROs used in Illinois to remove arsenic. But in almost every case, if it's over the recommended level of 10, it's still well below any kind of level that might be at risk for other types of exposure like skin, so like for in the shower and that sort of thing. So I just threw out here as an example, so say your arsenic level is 50 ppb, even if it's 200 ppb, which we see in Illinois in some cases, there's really no need for a whole house filter. You can still, it's really just, you don't want to ingest it. So you'd be looking at your kitchen tap for your cooking and drinking water. And I don't think we see very many whole house filters, do we, Dan?
I don't think I've ever seen anybody with a whole house reverse osmosis unit. We have one in the lab, but we have to have the ultra pure water for standards and calibrations and things like that. So you'll find different. It'll be different for cleaning and stuff too. It's just not, you don't need it, as Steve already said. Generally speaking, I have seen some people. One person really wanted to get the utmost they could out of water purity, and they weren't happy with the reverse osmosis water, so they doubled it up, like had a storage tank and reverse osmosis on reverse osmosis. Just realize that's going to take it's going to waste a lot of water. They waste like about 75% of the water that comes into them. I've read that some units may try to use that in other applications in the house, but in addition to if you had a whole house unit, like Steve's got here, it's going to be expensive initially, and then also ongoing for your water bills. If you were, I guess you're not on a city supply, but still you'd be using a lot of water.
Yeah, and so an RO unit also, because it takes so much out of your water, can make it lower the pH, which might make it more corrosive as well. So if you have it on a whole house system, and it's running through all your pipes in your home, then on an older home, it could cause some lead problems possibly, versus if it's just at the kitchen tap, it's not running through all those pipes. So it's just things to consider if you're going to go that way.
Can I add one more thing, Steve?
Oh, sure.
Usually with reverse osmosis, they want you to have a pretty good water quality going in. That means removing the iron. I think usually also having it soft. So in addition to the cost of the unit itself, you'd be looking at another couple thousand probably for at least a softener and perhaps an iron filter too.
Okay, thank you. So what are your thoughts on water quantity testing? There's certainly areas in the country where there's not much groundwater available, or it's really low yielding. I know one of the examples I use sometimes, a guy contacted us who lives on the western slope of the Rockies. His well only pumps about half a gallon a minute. And so he's developed a system where he's got a 3,000-gallon cistern, and he basically has a really low volume pump that pumps continually into that cistern, and then he pumps from the cistern into his house to get his pressure and have enough water. Because otherwise he can't wait for the pump to kick on in the well. His well just won't produce that much. So when you're in an area like that, or low yield, I mentioned here low yielding bedrock aquifers in Pennsylvania, we know there's areas there, partly when looking at some of the issues related to fracking and stuff, where these low yield wells, the water level may change by 100 or 200 feet just because they've kicked on to run a washer or a dishwasher or some of those things. And that can really affect water quality, because when a certain kind of rock is always underwater, then it's not exposed to air. And once things are exposed to air, then you can form oxides like iron oxide, but also a lot of other oxides. And so that continually going up and down in the well, if it's a bedrock well where the actual, there's no casing, it's actually the rock that is the casing, can really mess with your water quality. So so the problem when doing this as far as water quantity testing, because I know there's a few states that actually have as a rule, you have to show that it'll provide a usable quantity of water. You know, I even know hydrologists who refuse to do that or sign off on that just because there's no way to know that it represents the year-round condition. If you conduct a test today, it may be during a wet period or a dry period, either way. But if you're in a drought situation, I know in 2012 in Illinois we had a pretty extreme drought, and we saw things like wells that have always flowed. So sometimes the pressure in the aquifer is such that the water will come out the top like it's bubbling out, or wells that have flowed for 50 years and never had a problem stop flowing. And so to really be able to quantify those things and understand it, it's really tricky. And it's not something you can do just by going and doing an inspection or pumping it for a few hours. And then, who's going to sign off on that? Who pays if something happens 2 years later? We have people in Illinois that have dug and bored wells where after 1 or 2 dry summers may be hauling water and using a 1,000-gallon tank hooked into the side of their home for their water supply. There's several counties in Illinois where that happens. And so, I don't have a good answer for that other than it's a good idea to have possibly some kind of disclosure requirements. And I would contact either your state water survey if you're in Illinois or your state geological survey in your state to find out about well yield, water yield, how, if there's any kind of potential yield for aquifers in the area you're at. And there'll be somebody at one of those agencies who can give you that information. If there is an aquifer there, what the yield is typically, if there's any other old aquifer tests from a community water supply. And I'm getting some terms you're probably not familiar with, but if you're really interested in this question, give me a call or email us and we can talk about it more. Because it's a tricky situation to say, yeah, this well's just fine. There's too many things that can change from one year to the next that affect the water level in certain types of aquifers or wells. So, yeah. So that's the questions that I listed, and hopefully Katie's got some more from you guys. But I want to quickly talk about our class if you're not familiar with it. So it's a series of 10 lessons. You sign up on our website, and it sends you one lesson a week for 10 weeks. And, our webpage has a lot more to it, videos, podcasts, recordings of these webinars, and so a lot of good information. The idea is to help well owners understand their role as a well owner and what they need to do to, be a good steward of their well and protect their drinking water. So the lessons go from all the way about here's a hydrologic cycle and how water gets into the ground and into your well, to issues with contamination and well construction. Some of the things we talked about today, why does my pump kick on and off every 10 minutes? Well, you've got maybe a leak in your pressure tank. Or there's a lot of reasons why some of those things happen. More information about types of treatment, how they work, some of those issues. This is what our front page looks like. And if you click on Learn by Email, there's a place to sign up then for the class. And the audio and video take you to those pages for podcasts and videos. So this is what the page looks like to sign up. It's just your email address, first name, and where you live. And that's really to count, to show the US EPA who funds this program through RCAP that we're actually reaching nationwide. And it is. We've had a lot of folks from all over the country take this class, over 5,000 actually. I mentioned we record our webinars. This is the one from August 30th on lead. And so you can go to our videos page and then click on webinar recordings and find this. And you can watch the whole thing if you want, or find topics there. And we also created a bunch of these short videos, like how does my private well system work, or how does my pressure tank work. Ironically, they're like 3 to 5 minutes long, and the one on how does my pressure tank work has had over 60,000 hits in about a year. And so that tells us that a lot of people are interested in how their pressure tank works and don't understand it, as well as there might not be a lot of information out there for people on pressure tanks and how they work. So along with each lesson on our webpage is a resource library of other links. So for lesson 1, there's all these other documents you can download. They're all free, publicly available documents that give you more information about those topics. And then as far as our partners, which we consider, realtors, labs, environmental health professionals, all of you folks as outreach partners. So you can sign up here to get our newsletter. And that's really what it entails. And if you scroll down this page further, under partner resources, you'll see our past newsletters. You can get an idea if you think they're interesting or you're interested in what's there. But we provide a lot of useful information on programs going around the country, other people that are doing classes for well owners, things like that. And this is just the front page of our newsletter from last February when we launched through NEHA, the National Environmental Health Association. We launched a version of our class that's for sanitarians, so they can take our class and get CE credit, which they need to maintain their license. So, it's pretty useful, and it's not meant for well owners. It's meant for those that serve them, including realtors. So, it's useful stuff. We've also developed the Realtors page, and you can it's privatewellclass.org/realtors, and there's information here, and then a link back to join our partner community, and you can take a look at that. And so the bottom line is what we're trying to do with our entire program is really help people understand why their well is important, why they need to understand how it works, and how they can protect themselves from risk so that they're more informed, they can ask better questions, they understand who their local sources of information might be. So we're trying to give them tools to be a more informed well owner. Because again, if you own a private well, or even if you have a spring, you're really the water operator for a very small water system. And you need to do your due diligence to understand how that works and make sure that you're doing things in a way that's going to keep it safe and protect your family and their water quality. Said 2-minute break here, and then we'll go to the webinar questions. It looks like we have, I'm going to just pull this over. It's already almost 2:30, so I'm going to see if that goes on top. It does. Okay. So these are the questions we have today, and we're just going to go through these real quick. Let me make this a little bigger. There we go. Can we get a copy of this form from earlier in the presentation? Yeah, if you email me or email us, you can also look on Wisconsin DNR's webpage. Thank you, Katie. If you contact us, we can give you that link. It's an online form. It's a downloadable PDF that's fillable. And again, you can also search for it on DNR's webpage in Wisconsin. So it says, will a test come out differently if the property has been vacant for several months to a year, water has not been through the system? It certainly can. It just depends on the property, the type of pipes they have. There's a ton of factors depending on the water quality, whether that will happen. Any type of scale that forms or anything that sits and sediment develops, I would certainly run the water for a while. And I don't have a good feel for a vacant home and what can happen. But, as long as the water's always been under pressure, that's one thing. But if, for instance, if the power's been shut off and it's possible that there's been backflow into the well so that the pipes aren't under pressure and they're not flowing and they're exposed to air as well in the pipes, then you could certainly have a lot of things formed in there that, if you have a filter, I would think, Dan, what do you think? I think it would probably be pretty nasty.
Yeah, I agree, Steve. You had a good answer. I would expect it. The water itself, I guess, once you got it pumped up from the well, if it were a deep well, like Steve had mentioned before, I wouldn't expect it necessarily to change at that point if it's a deeper well. But all kinds of things could be different in the house. I suppose, if you're in a house that sits over the winter, they're probably, turn the pressure off and empty the lines to prevent freezing. So that might Yeah, I haven't really addressed this question before. I would
Sure.
say flush the water a lot.
Well, and as far as a home that's a seasonal home, there's actually, we've put out, some of the states have recommended best practices for homes like that, or actually for non-community systems that might be seasonal, on how to, to ramp them up and how to decommission them for the winter or whatever. Um, and Katie, do we have that somewhere on a web page or in a blog post maybe?
We might.
We can certainly get you. I know the state of Washington has one, and maybe the state of New Hampshire has a good brochure that talks about, what to do when you're with a seasonal property, as far as to protect the lines and make sure that, one, for freezing, and two, for water quality, and what to do when you start out.
I believe it's in. It's probably under the resources tab on our website. So.
Oh, that's probably right. So I know we just got a call from Health Canada. They had a huge ice storm up in northern Canada where the temperatures were going to be down in the minus 20s. And so they had folks put food grade antifreeze in their wells, the kind that's not harmful, to help keep from the wells themselves actually freezing. And so hopefully we don't have to go to that kind of level of risk, but it's just interesting how, depending on where you live and what your situation is, how different you might deal with something like that. So, okay, so could you talk a little about your thoughts on the PFOA and PFOS contamination? We are starting to see issues related to contaminated wells in Massachusetts, New Hampshire, Vermont, and the EPA advisory. There's a lot of information out there. I was at a meeting in August that EPA had where this was one of the subjects of discussion, and there's a public health advisory. EPA may have came out with something as well, but I know somebody from EPA in their Office of Water said at the time, if they started working on a rule now for PFOA and PFOS for community water supplies, it would be either 6 or 7 years before that would take effect. And so really we're leaning on our health departments, I think, as far as what to do about those things. And I know it's a lot in the Northeast, especially in like Vermont and New Hampshire. And so as far as what my thoughts are, I haven't really looked into that issue as far as what folks can do. There are people who have, though, and I know for this EPA meeting I was at, they had someone speak about this issue specifically, and I'm thinking that their presentation might be available online. So if you'll email us, we can try to find that, and I can ask. It was a joint meeting held by US EPA and ASDWA in August. And so if that presentation's available, we can at least get you that information. Yeah, that's all I know. I'm sorry I don't have more information there. So, but there are folks like at EPA in Cincinnati who might be able to help us there and give us more information. Okay, for realtors in states with no regulations in their state on what to inspect or what to sample for, they may try to get their real estate association to establish standards for realtors of that state to follow. That's a great idea. I think, in the end, one thing I didn't mention, I'll mention now. We're losing some folks, but, there were several people who asked questions basically trying to, how can I get through this as quickly and easily as possible? And for that, there was also someone who said, I want to make sure that we're doing things the right way and that people are informed and, blah, 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 blah. And I see both sides of that, especially, sometimes it can slow down or even stop a sale of property, and that's certainly not in your business best interest. But I think rather than trying to take the easy way out, if you will, trying to establish these standards and bringing everybody up, bringing the bar up for everyone so that everyone's on the same playing field is certainly a better way to go. And so that's a great idea. So thank you. Well inspection services are not contracting or repair service. A well inspection is a consulting service. A realtor is a consultant, and a well inspector should be one also and have consulting insurance just like a realtor. Okay. they're not certainly not a contracting, and when I say a contractor, that's a term that's used in well construction. So the guy who drills a well is a well driller, or it could be called a well contractor, or the guy who installs a pump is a pumping contractor. And I understand inspection is a consulting service, but in some states, like in Wisconsin, the well inspection has to be done by a licensed contractor, a well contractor. So the fact that it's a consulting service, sure, I would agree. And they probably do have consulting insurance if they do that work. I know a well driller in Arizona who does a lot of these kind of inspections, and he has a lot of frustrations because of the rules there, but he certainly carries that kind of insurance, and there's certain things he won't do just because he can't put his license on the line for that, like the water quantity stuff. Sometimes there's no way to be sure that a well will actually produce 2 years down the road just because it produces today in some situations. So yeah. And I would imagine that most folks acting as well inspectors do have that kind of insurance. And I should also mention that we were contacted by one of the home inspector associations, and they're now using NEHA's class that we provided to also give their home inspector CEUs for their license in some places. Okay, is that it, Katie? Yeah, okay.
That is it.
All right, well, thank you, everyone who stuck around and for your time. And again, this is recorded, so if you want to share this with folks, that'd be great. If people have other questions, you can email us. And Katie and Dan, thank you for your time as well.
Thank you, Steve. Hey, a quick thing about certificates of attendance. If what I can do is if you attended the webinar today and you would like a certificate of attendance showing that you did attend for the full 1.5 hours, so you could attempt to submit it to your state or Realtor Association's credentialing agency, you can just send us an email. We can provide you with the slide deck PDF and anything else that you might need, and you can email us at info@privatewellclass.org.
All righty, well, thank you again, and with that, we'll sign off.
Thank you, Steve.
Thank you.